Hello, welcome to Desert Dioro's training videos. Just kidding. So we were talking about doing some training videos, or I heard we might start doing some training videos. So I want to just break the ice and try a simple one out. And then maybe more, maybe after that, more people will be encouraged to do their own. And we can just kind of learn from each other. I figured I'd start with a simple piece of equipment that I think most of us all work on, the Star or Middle Bay Advantage clamshell grills. Some people call them split top grills. I was hoping to actually use one, but we didn't have one available for me to use. So instead I have the components that you run into. First off, I just want to talk about what we'll typically see when you're troubleshooting these. A lot of times you're going to see either probe 1, which is, the probe going to, it's going to be the E1 and E2 terminals, or you'll see probe, and that's going to be your upper left. If you're facing the machine, that's going to be your upper left top clamshell grill and the probe associated with it. Or you'll see probe 2, which is going to be your right hand side upper heating element / probe, and that'll be the E11 and E12 terminals on the board. Or you'll see probe 3, which is going to be your main, your main bottom heating element. Some of the other things you'll see is relay. It'll just say relay. Or sometimes you'll go, by the time we make it to the call, we won't see anything. All we'll see is that it's flashing. And that tells you right then and there that it's not working like it should be. Sometimes it'll even be pretty close to temp. You can pull out your little pocket, your laser thermometer or something like that, and it'll be like 500 degrees and you're 500, 510. You're like, oh, nothing's wrong. But if that thing is had time to move up to temp and it's still flashing, that means there is something wrong with it, even if it is up to temp. Especially if you don't see the heat, there's a little heat. Sometimes it's a dot or sometimes it'll say heat on it. If you don't see that, that means that it's not making it up to temp, even though it's had sufficient time to call for heat and try to heat itself up. The other thing is to keep in mind is that even though it says like probe 1, probe 2, probe 3, that doesn't mean that it's necessarily a probe. I've seen a lot of techs, they just immediately go buy a new probe, change it out, and then it's the same problem. So what can happen is if there's any wiring leading up to that probe, that can throw a probe fault. If there's a bad relay, that can throw a probe fault. If there's a dirty sensor, so this is the part that goes near the heating element. If it's, sometimes it'll get covered with like calcium buildup, or sometimes that heat lubricant they put on there can inhibit it from working. So checking to make sure that's clean a lot of times will solve the problem. But before you do anything, we'll get into how to troubleshoot it. That way you're not just being a part swapper, or you're just shooting in the dark hoping something works. According to the manufacturer, 80% of problems is the probe though. So most of the time, this is going to probably be the first place I start because the manufacturer usually knows best their equipment. And what else, just so you know, and I'll attach a wiring diagram and also a little mapping that tells you which probe goes to what terminal and all that stuff. But basically, this goes on the heat element end, and then these two connect to your board. I don't have a board here, and then your once it reaches temp, that tells your board to disengage one of the relays. There's two styles depending on how new of a model you're working on. Or actually, there's 3 styles now with the newest kind. I don't have those here though. But so it goes sensor, and then that goes to your board, and then your board tells the relay to kick on and off, and then your relay is what sends power to your heating element. And then obviously your transformer is what's going to send your low voltage to your board. So we'll start with, say you have a probe 1 error on there. So if you look up the manual or the wiring diagram, or you screenshot the mapping that I send everybody, if you see a probe 1 error, you'll see that it's going to be terminals E1 and E2 on your board. So usually what I'll do is check. I'll start with the probes, and it really doesn't matter which one you start with. So these are two. So if you look on a new package, you'll see a rating for any probes that you buy. It doesn't have to be this piece of equipment. Any heat sensor or probe is going to have a rating. So like this one, it says 2K. So at room temperature, it's going to be around 2,000 ohms or 2,100 ohms. That's around room temperature. Obviously, a lot of times when we're troubleshooting this stuff, it's not at room temperature, and you're not going to know exactly what resistance you should see. But what you're going to do is you're going to take it off the board, and you hook up your leads on your multimeter, and you set it to ohms. I won't go too much into how to use the meter, because maybe we'll do that in like another video. Maybe somebody else will do another video on ohms, resistance, using your meter, stuff like that. But this is just specific to the clamshell grills. So you'll take your ohm reading, and like I said, we don't know the exact resistance we should have unless we're at room temperature. At room temperature, we should have 2,100 ohms. But if it's hotter than that, if it's already started heating, or it's close to temp, you're gonna have different readings. So what I do is I just check all of them. So check all 3 of your probes, and whichever one is different than the other. So if you have 2 that are the same and you have 1 that's off, that one's where to start investigating more. And that doesn't necessarily mean that your probe is bad, because it could just be that heating element's not engaging, or that relay is not engaging and heating up. So of course it's going to read differently, but where your problem is at least. Then from there, I would go on to the relay. I'll start with this style relay. You can look on there and it'll map it out. It'll show you which terminals are normally open, which are normally closed. It'll show you, usually have some kind of indication of which one's your control voltage and which one's going to be your actual, your 120 volt. So your control is obviously going to be coming from the board, and when it gets the right control voltage, that's what tells this relay when to open up and feed power to your heating element. Some of them you'll have normally one leg will be energized all the time, and then the other leg doesn't get energized until it receives the proper control voltage. Some of them you'll have both legs coming off the relay. Some you'll have one leg coming off the relay and one that's already coming off the main terminal. It just depends what equipment you're working on. But the easiest way if you don't know all of that, then the easiest way is just to check each relay. I think there's 3 of them, or in most models there's like 3 of them, and you just confirm. And you have to be really careful, because obviously we can't check relays. A lot of the work we do, we have to do under live voltage, so we can't check it with the machine off. So obviously, while following all of our safety procedures, you're gonna just check which relay is the odd one out, just kind of like what we did with the probes. If you have your unit calling for heat, and you can check that by seeing that little dot, or you can see it flashing, then it's calling for heat. So the board's supposed to be telling this relay to call for heat, and then you just check which one isn't getting it. So, for example, normally I would have and I don't normally check my control voltage, but you can. So you check to make sure you have 10 volts here, and then here, one of these is going to be your common, or two of them might be your common or neutral, and then you're going to have two that are going to have 120 volts coming off of them, or one coming in and one going out, depending on what you're working on. But basically, if you see two relays where, you know, this terminal is hot and this terminal is hot, but then you get to one relay and this one's not hot, you know that relay is not opening like it should be, or closing depending on how you word it, but it's not sending power to the element like it should be. And you know that relay is bad if it's not sending power when it's calling for heat. As long as it's getting the right supply voltage, it should be sending or if it's getting the right control voltage, then it should be sending power to the heating element. And so I just check all three of them and see which one's not working. If one of them isn't working and it's getting the proper inputs, then you know that relay's bad, replace it. If it is working, so it's all set, you're getting the proper voltage to your heating element, it's a good chance that your probe's just dirty or it's bad. And so you replace the probe. You can check the heating elements, you can ohm them out, you can check, I don't remember off the top of my head, but you can find in the manufacturer's literature what the proper ohms is for that element, but it's usually not the heating elements. So I tend to check that almost last. And then if you're still getting, it's not, you've figured out that the probe is doing what it's supposed to, either you ohmed it out, or you know your relay is good, you know your probe's good, but you're still having problems. Sometimes you'll even get like some wonky flashing on the screen, or not the normal flashing, but you'll get like, just like part of the screen's disappearing, fading away, or it'll show like numbers or symbols you've never seen before. And a lot of people, they just think the board's bad, or sometimes you're not getting your proper control voltage, right, to your relay. So obviously it's not going to do its job. People condemn the relay, but it's actually the board not sending power what it should be. And so the next step is people condemn the board. And we all know a rookie who, immediately always thinks the board's bad. So we don't want to be that guy, right? What I would check, and what the manufacturer suggests, is that, I don't remember the verbiage that they use, but they basically say it's almost never the board. So if you suspect a bad board, first, before you condemn the board, check everything else. Check your relays, check your probes, and also check your transformer. So I'm not going to go over, how a transformer works. Maybe we'll do a video on that another time. But basically, if you're getting over 13 volts coming out of that transformer to your board, your board may not operate right. Sometimes it'll be doing that and the board will still work, but then intermittently you'll have problems. So check that voltage going to your board. You should not have more than 13 volts DC going to your board. If you do, it can cause the board to do wonky things. It can cause your relays to do wonky things. So check that. And then finally, if you checked your transformer, your relays, your probes, and there's nothing else, then the manufacturer says it might be the board. And they don't have a specific troubleshooting for the board. It's basically eliminate everything else and then the board last. So that's just a video, my experience with the Star Grills. I'm no expert, but that's a simple piece of equipment, so I figured even I could do a video on that. and I'll try to send a wiring diagram and a label that tells you what goes to what for each probe and everything. And if you want to screenshot it, you'll just have it on hand. For some of you newer techs that aren't used to these grills, it might be beneficial or helpful for you. So yeah, hopefully that helped.